Okay, good morning, Anbazhagan and Arjun. Today, thanks for coming to the session. Today, we are going to deal about the Josephus problem, which I would have mentioned to you previously. Basically, Josephus problem is a famous data structures and algorithm problem, which was given, it was created long back by in mathematics and everywhere, and we have a data structure solution for that. So basically, now today in this lecture of 30 minutes, we are going to think about how to solve the initial mathematics problem the first, and then to create a normalized generalized solution using the recursion which you would have learned previously, or I would have explained it in the meantime by explaining to you, like by asking questions to you on how much you understand what. So let's get back to the first initial basic problem and then to the uh, data structures problem. Uh, Basically, to distinguish between data structures problem and the normal problem, in the data structures problem, first I will explain the normal question and then I will say what is the advancements that is in the lead code question or the geeks for geeks question which will be seen. So first, this is the normal problem. I will say you the story of how the Josephus name or how the problem is created. So the problem is during some World War time or some previous time you can assume, these yellow color people are Jewish soldier or the ones in the uh, Europe side, and that is also from Roman side, Rome soldiers. So basically, these soldiers got surrounded by the Rome soldiers. So basically, you can think like our our okay, I don't want to go like some Indian soldiers or some British were surrounded to Indians, like let's assume like that. So what they want to do is they don't want to killed by the enemy, so they want themselves to be killed so that they will not be killed by the enemies. So what they decide is they are going to make a circle, and each one in the circle is going to kill the next person to win. Suppose we are making a circle, I'm going to kill my next person, and that next person is going to that next person. So basically, it goes like this. Let's suppose, okay, my pen is visible. Let's make this guy one. So pen color change it. Pen color. Okay, I'll change the pen color. Pen color. Pen color. Wait a minute. Let me change the pen color of the
அண்ணா வாய்ஸ் கேட்கல.
clear. Now audible. Arjun Baker.
ஓகேண்ணா.
Okay. So thing is, if this is the number one person, he will kill the right. He will kill this person in his right hand or left hand, whatever. So he'll go in a circle way. That will be even more easy. Let's make it 1, 2, 3, 4, 5, 6, 7. I would make it a bit bolder. Let's put this one. Make this one. Color is okay. This is 8. This is 8. Still not visible. 1 minute, 1 minute. This is 8. This is 9. This is 10. This is 11. This is 12. So what this person will do is one will kill the 2 by using the sword, and this 3 person will kill the fourth one, and this 5 will kill the sixth one, 7 will kill the eighth one, 9 will kill the 10th one, 11 will kill the 12th one. So this all is done. So now the remaining people are 1, 3, 5, 7 should be there, right? 7, 9, 11. So now this one again 12 is killed, so powers came to 1. 1 will kill the third one, 5 will kill the seventh one, 9 will kill the 11th one. And then again 1, 5, 9 is there. 11th one is killed, so powers again came to 1. So 1 will kill the fifth one, 9 will kill the first one, 9 alone is the remainder. So what this last person, the problem is everyone should kill the next person to them. So one will kill like in a circular manner again and again, and only one last person will be remaining at every time. As it is a circle, you can't like there should be someone as they are killing each one others. If someone is killing you means one of them is left over. It's not like both can kill each other. So So only one person will be left over in every case. If how many ever members you take. Let's suppose it's 9, 10, 11, 12. How many ever numbers? It's in the original problem it was 41 members. So one will be left, and Josephus want to be that one person because uh, is the audio clear?
Yeah, it's clear.
Yes, Anna.
Okay. Josephus want to be that one person because let's suppose all the 40 all this remaining soldiers are killed. If he's that one person, instead of getting suicide, like the idea was not to get surrendered to the enemies. But what Josephus was thought is let's all get killed, but let's be the last person standing and get surrendered to the enemy so that we will get our life, so that he will get his life instead of getting suicide, which was against the team idea, but still he chose for that. So now what we are going to do is find a position for Josephus where he can stand. In this case, if you have seen, ninth is the position. Ninth person is the one who is going to leave. Now we want to find the position of Josephus where he is going to stand so that he will not be killed after by his own team or by his own country. So he wants to stand and get surrendered to the enemy team or captured by the enemy team rather than getting committed suicide. So if other person, if instead of like two or three are the ones who have decided for this plan, what they will do is they will get commit suicide and will not go to the enemy team. But Josephus wants to stand as the last person and get captured by the enemy team and not get killed. So that was his whole idea, and that's where the first question was arised. This question came from that large worldwide idea. So in that one, it is a mathematical problem. So let's suppose I'm asking a question. In a circle of four people, I want you guys to try it out. I want just you guys to think it out first. In a circle of four people, where should you stand so that you will not be killed? You will be the last person standing. The question is now the last person stand. So let's reframe the question. Okay. Okay. That is just 1 minute. 1 minute. Okay. Yeah. Uh, okay. Who is the last person standing is the question. Who is the last person standing? Okay. You guys think it on your mind or in a note and say me. Who is the last person standing? When four soldiers are there. Four soldiers are there. Which means a circle of one, two, three, four. It should be symmetrical, but I want to know who is the last person standing from me. Okay. Okay.
So first the knife. Person one will have the knife first, right? So one will kill two, pass the knife to three, three will kill four, pass the knife to one, and one will kill three. So one will be stuck.
Okay. Set in the mind. Anbazhagan, can you also find it?
Yes, Anna. One will remain.
One will remain. How you said?
Uh, First person, one kills two and three kills four. Then remaining one and three, and one kills three.
Okay. One kills two, three kills four, one and three. So three also kills. So one is the remaining. Okay. So for n is equal to four, we can say that one is remaining. One is the best position or one is the last survivor. But for n is equal, like we want to find for any n. In mathematics, we can't say for this value, this is that by drawing entire circle. So what we are going to do is we are going to generalize an equation or a formula to find where this guy should stand. Okay. So now the question comes. Let's suppose we can do this in some 15-20 minutes or some days. We can solve this problem in computer science and all, like it will be even more even more generalized. How it will be generalized is now we are killing the person next to us. But when the input or when the in computer what you will do, you will give an input and then will ask the computer to say the solution. In this case, it is just a one case where you are just going to kill the next person. But a user may come and ask, like a new user will come and will ask that I'm going to kill the second next person or I'm going to kill the third next person or I'm going to kill the fourth person and then circulate. So in that case, the k value or the one like now you are killing the adjacent person, right? That is, let's suppose that is as 1 or 2. Let's keep it as 2. In that case, k will be changed to third or fourth or fifth. You will be the one and second person you are killing. So k is equal to 2 is our case. But what we will do is we will change the k to 3, 4, 5, like depending upon the user input. So in that case, we want to write even more generalized formula that we will do with the DSA recursion function calling and all. That we will look into later, but we'll just now solve the k is equal to 2 using mathematics. We'll see how it goes, and then we'll get you with the idea of generalized way in which different k is getting solved using easy function calling. First, we'll start solve this, and then we will move to later. So, any idea on how to solve this problem that you are just killing the adjacent soldier one by one, and who is going to be the last person? Yeah, think for a minute and answer. And I believe this problem is new to both of you guys. Like you haven't seen any of this previously, right? Both Arjun and Anbazhagan.
No, I actually came across this problem. There was 100 people and then we did the same thing. I think 73rd person will be the last one standing. I don't remember the logic exactly, but it's like you identify the nearest power of 2 that is there to the total number of people. Let's say there are 100 people. So the nearest power of 2 is 64. And then, I don't know, you eliminate 64 people and then you go on from that point. I don't remember how we exactly do that, but I
Okay,
did come across this problem.
okay. But the logic, uh, what Arjun said is like a close to answer, but he didn't say that clearly. Okay. What Arjun said is like close to the answer, but he didn't say it clearly. What we need is we are going to derive the logic. We are going to derive the idea or the formula. So that is the whole point of this class. So yeah. No, I want you to do. So you, both of you don't know the solution. So I want you to find out we can find a solution for this. Okay. Think for a minute and let answer. We'll see. Yeah.
Anna,
Ah.
using arithmetic series, let a common difference as k value.
Hmm.
Can we solve?
You can solve, but thing is, after every circle the number changes, right? Let's suppose you're going to 1, 2, 3, 4, 5, and it will again come to 1. So number can be anywhere. Like it is not just increasing, so that you can say that it is arithmetic series. It comes close to that. The common difference is a good idea, but just using a series is not a good option. You can think on the idea of series, how it can go. So you said for 4 soldiers, the answer is 1. This is the hint I am saying. For 4 soldiers, we got the answer as 1. For any number of soldiers, what is the answer? For n soldiers, what is the answer? Yes, what is the solution? Okay, can I give a hint? Can I give a hint or
Okay. I have a logic, just listen if it's correct or not.
okay?
So if there are 4 people and person one starts killing, person one will be the person who's going to stand at the end. He'll be
Yeah,
the survivor. So maybe you can try it for another like 8 people because 8 is another power of 2. So if we tried it for 8 people also, I think person one will be standing at the end.
Okay, that's a good approach. Okay.
Okay, so what you can do, you have 100 people now. Let's say for 100 people, like if you want to try for a more larger number, 100 is not a power of 2. So what you do is you start killing normally in the first round and you identify the point where the total number of people is actually a power of 2. Like for example, if there are 100 people and you do 36 killings, so 100 minus 36 will be 64. 64 will be a close power of 2. So when there are 65 people, if you can identify who has the knife, that guy will be the person who's going to survive at the end.
Okay. Uh, though, okay. Well, though it's a good approach, the idea of two power which you said is correct. Like the idea is correct, but the answer will not be got by the way. Like basically a hint or the way in which you are going to derive the solution is you are going to list out the points. Like basically how we will find the pattern. When we have a list of certain numbers, we can find the pattern. But here what we are going to do is we are going to list out the points to find the pattern and then the pattern to solve the solution. Okay, Arjun is having panic scene. Okay, that is not a problem. The problem is you are, to find a pattern or to find a logic, you need a set of list or a points. So that points can be found out when you are going to write some certain values for that and then analyze the logic. So what we are going to do is we are going to write for 1, 2, 3, 4, 5, 6, 7, 8, 9 up to like you are set for 4 and 8. But we are going to make it generalized and for go up to 9. And then we will think if we can find some pattern up to that. If we can find, we will go on. Or if there is nothing that, we will try to switch the pattern. So I will try to write for you guys for the like I mean the first three. Yeah. Okay. It is in the thing. You can also join with me and write on your own, whichever is comfortable. Okay, this is not getting visible. Okay, your video is not visible. I don't know why. Let's close this. 1 minute, 1 minute. Okay. Okay. Only mine is visible. Still myself here. Okay. Let me go to this one and then let me click escape from here. 1 minute delay. Sorry for that. Okay. Now it should be visible. Okay. Okay. Let's go. So what I'm going to do is, okay, I will say another thing. In the Josephus, in the real life situation, he is going to sit in a 41 soldier circle. Is in 41 soldier circle. 41 soldier circle. Okay. So in a 41 soldier circle, he is going to stand. So we will think on that perspective. So which is n is equal to 41, where he wants to stand. So we will find our formula and we'll go to a location and make Josephus stand so that he will get a slide. So that is our whole point of idea. So before that, we will first move on to finding the set of points. Okay, I want you to know for one, what is the solution? Okay, it is so easy, it is one. So for two people, n is equal to 2, what is the solution?
So solution means you mean who survives the game, right?
Yeah, who survives? One, two, two. One will kill the
One
two,
will only
so
survive.
one is the one survivor. Understandable, right? So for three, can you say?
For three, it will be three.
Anbalagan, can you try? One, two,
Yeah.
three. Three you are saying, okay. Two is killed, three will kill the one, so three is a survivor. So for three, three is a survivor. For four, you said previously it is one, right? So I remember that, I am keeping that. So for five, can you guys find and say what is the solution? Okay, I will write for you. You'll think accordingly. So it will be easy for both of us. One, two, three, four, 5. So in the first round, 1 will kill the 2, 3 will kill the 4, 5 will kill the 1. So after that, 3 will again kill the 5. So 3 is a survivor. Okay. Is there any doubt here? You can also try in your own in the note or notebook which you are having. So for 5 people, third location is a survivor. Third location is survivor. Okay. We'll go step by step slowly. If you have any doubts, you can let me know. For 6 people, can you let's get the guess. 1, 2, 3, 4, 5, 6. So 1 will kill the 2, 3 will kill the 4, 5 will kill the 6. And then 1 will again kill the 3, 5 will kill the 1. So 5 is a survivor. Okay. Understandable, Anbazhagan and Arjun?
Yeah, yeah, got it.
Okay. So for 7, let's try a case and find out. Okay, I will find it here in this place. So I'm not wasting any place forward. Okay. 1, 2, 3, 4, 5, 6, 7. Let's go fast so that we won't waste the time. So 1, 2 will be killed by 1, 4 will be killed by 3, 6 will be killed by 5, and then 7 will kill the 1. So 1 is also gone. So 3 has another sword. So 3 will kill the 5, 7 will kill the 3. So 7 is a survivor. So for 7, 7 is a survivor. So for 8, we will check. This is going to be interesting now. For 8, now I am going to take a different color. Let's take a different color. Let's go. Let's take a red color. So color doesn't matter though. For 8, let's draw a circle and let's put 1, 2, 3, 4, 5, 6, 7, 8. So 1 will kill the 2, 4 will be killed by 3, 6 will be killed by 5, 8 will be killed by 7. So all the even numbers 2, 4, 6, 8 is eliminated. Now 1 has a sword, so 3 will be eliminated. The 5 has a sword, 7 will be eliminated. 1 is the sword, so 5 eliminated. So I'm just saying that first 2, 4, 6, 8 is eliminated. 1 has a sword, 1 kills 3, and 5 has a sword, 5 kills 7. Now 1 has a sword, 1 kills 5. So 1 is the remaining now. So if you see now, it is again turned back to 1. If you see now, you can previously see that the series is increasing 1, 3, 5, 7. But suddenly in 8, it got again back to 1. So there is some pattern which is coming. Like see, the series is increasing, but it is decreasing again. Like you can't know the pattern. Like as Arjun said, if you exactly look, it is at the 2th power. 2 power 3, 8, it is resetting to 1. 2 power 4, 2 power 2, 4, it is resetting to 1. 2 power 1, 1, it is resetting to 1. So you can have an idea. That is what Arjun said. Like he has some idea, but through visualization or through by writing itself, we can find the whole approach for that. That is not a problem. So okay. So now we got this one. So can you guys guess what can be for a 9? What can come for 9? Any guesses? It's almost about the like we got enough data points. We'll just get two more, three or more data points, and then we will find to get some logic. Okay, can we draw? Okay, the best way should be draw. 3 is the correct answer. Well, but just I think you found by drawing, right? Not by logic.
Yes, sir.
But you should find by logic. On that case only we will stop the data points. If you're just drawing it, we will find a logic and then only we can stop. 3, 4, 5, 6, 7, 8, 9. So 2 will be killed, 4 will be killed, 6 will be killed, 8 will be killed, 1 will kill 3, 5 will kill 7, 9 will kill 1, and then okay, I just sorry,
9
sorry.
will kill 1 first round.
Okay, sorry. 9, I made a mistake. Okay, let's write like this: 1, 2, 3, 4, 5, 6, 7, 8, 9. 1 has a sword, so 2 will be killed, 4 will be killed, 6 will be killed, 8 will be killed. And 9 has a sword, 1 will be killed, 3 will kill the 5, 7 will kill the 9, 3 will kill the 9, so 3 is the solution. So 3 is now the solution. So for 10, what do you think is the solution?
5.
5, how you said?
Uh,
How you said, can you say, explain?
in previous case, first start with 1, next 1, 3, next 1, 3, 5,
Uh,
7.
hmm,
Similarly, 1, 1 after 1, 3, after
okay.
3, 5.
Oh, so yeah, it is going in odd numbers or with the period of 2 or every like 2 difference is that common difference. So that is what we said in the previous case, like the common difference thing. So the 11, can you say the answer?
7,
7. 12, 12, can you say the answer?
Will be 1.
Can you try again? Okay, we'll draw for 12. Anbalagan, can you try?
9,
Okay, 9 is the correct answer. We'll draw again and we'll check it again. 9, 10, 11, 12. So 2 will be killed, 4 will be killed, 6 will be killed, 8 will be killed, 10 will be killed, 12 will be killed. 1 will kill 3, 5 will kill 7, 9 will kill 11, and then 1 will again kill 5, 9 will kill the 1. So 9 is the solution. So 12 we got 9. So if you see clearly, it is increasing 1, 3, 5, 7, 9. Arjun thought that it would reset on 12, but it is not resetting. Because if you have seen in the previous case, when it resets is, if suppose if it increased to 9, it will increase the, okay, it's not a problem. If suppose if the 7 is increased to 9, this 9 will be greater than 8. So that is not possible. You have 8 soldiers and you want to sit in ninth position. That is not possible. So I will sit on the first position. That is when that is when the number resets. So in that case, we don't have a problem. You can sit in the ninth position when we have 12 soldiers. So it will go up to the odd series will continue going on. So if you see for 13 it will come to as 11. For 15 it will come 14 it will come as 13. For 15 where it can come 15, not an issue. But as the numbers are same, it can still come. If you have seen previously any case where the 7 is matching with 7, so you can sit on the 7th position. But for 16, if you say it as 17, it will be a mistake. In that case, you want to reset it to 1. Is that understandable?
Yeah.
Yeah, it should make sense. And now you can find another pattern with this also. It is not resetting at some random position. It is resetting at 16, which is 2 power 4. Previously, it resetted at 2 power 3, 8. Okay. Now it is going resetting at 2 power 3, 2 power 4, and another previous case was 2 power 2 and then 2 power 1, which means every 2 2 power n, it is getting back to 1. So 2 power n, the value is 1. The survivor is at 1, and the sequence start, the odd sequence start after that. I won't say just the sequence, the odd sequence. The odd sequence basically the 12 plus 1 start after that. Okay, start after that. Okay, I guess that makes a lot of sense. Now I will give you a small number and you want to find that using this small line which I said or this line which you have inferred previously. So let the number be not 17. I will give 25. 25. I want you to figure out the answer for this. Let's zoom it out so that it gives much clarity. Can you try finding answer for 25? I'll show the sequence also. Survivor is at 1. Arjun, you are not audible.
Yeah, I'm not speaking.
Okay. I was just thinking. I've set you the given you the clues previously by showing the sequence. You can look at the sequence again if you want.
Will it be 19?
For 25 or saying 19.
25.
We'll check that one. Check that one. Okay. Before generalizing the answer, like generalizing it as a formula with this, we'll think on our idea, like what our idea is, and then we will try to figure it out. So our the number which I gave was 25. So 25. 25 is what we are having. So okay. This is going down. 25 is what we have. So 25 means it comes after the 16 is 1. 17 is going to be 3. 18 is going to be 5, which means it is increasing. Like for 17, what you can observe from this is the odd sequence is starting 1, 5, 7, 9. It is going like that. So somewhere the 25 comes. That is what we have to find out. So what we can figure out the equations from this is the difference here is just 1, and that is a 2 increase, 2 increase, 2 increase, 2 increase. So if you see, what you can do is you can subtract these two, the difference is 1, and if you put it in a 2l plus 1, the odd basic sequence, you will get 3. If you subtract this and this, and if you put 16, 18 minus 16 is 2, and if you put 2 in 12 plus 1, 2 into 2 plus 1, which is 5, you will get 5. So what you will do is the answer for this is 25 minus 16, which is equal to 9. We will put 9 there. 2 into 9 plus 1, which is 18 plus 1, 19. And Arjun was correct as per the logic. Anbazhagan, can you understand how we did it? Or should I explain again?
Yes, Anna.
Okay, you understood clearly. So from that, what we can say is, like we can just with this, we can say an equation for finding the answer. So the answer can be like this, the solution. I will like just a normalized thing we will write, and then we will make it more practical or more mathematical. Solution is for n number if you have given, you have to take the n and subtract it from the 2 power a, which is the largest a, some largest a, where a is largest possible. We'll just make it simple now, and then we'll make it more mathematical. You will get an answer for that, and then that answer you have to put in 2l plus 1. So the answer is 2 into l plus 1. This one is the l, some number, and that is plus 1. So if you put 25 minus 16 plus 1, this will satisfy. So this is a solution, but we will make it more mathematical. How we will make it more mathematical is this n minus 2a, we will make it as a term. The value which we are going to get is n minus 2a is equal to l. Okay, it is just a normal term. And the number, so basically why I am doing this is I want to make just in a mathematical equation so that anyone can find the anyone can put this in a formula and get the equation. So we have written a as largest and all, so that shouldn't be written. So we will make n minus 2a as l first, and then let's suppose a number is given as n. That number should be written in the format of l plus 2a, 2 power a. So if you get 25, you will written as 16 plus 9. 16 is 2 power 4. So the more mathematical, I am making it a bit fast as the time is going to end in the Zoom meeting. 25 is equal to 16 plus 9. So any n number, any n that is given to you, you will write it as 2 power a plus l, where a is the 2 power a is the largest exponential term that can hold, or what you can say is the difference should not have, or uh, just 2 power a is the largest is the fine, where a can be larger. A is the largest possible value. So you will, if you get a number, you will write it as 2 power a plus l, and from this l, what you will write is solution is 2 into L plus 1 is the solution. So that's what we have seen previously. This is L. So solution is 2 power L, 2 into L plus 1. And number should be written as 2 into 2 power A plus 1 is the first case. Is that understandable?
Yeah, it's understand.
Makes sense, Anbalagan?
Yes, Anna.
Makes sense. So let's go to the case of Josephus, where he has 41, where he is in the circle of 41 soldiers. So n is equal to 41. In that case, how can we write this n? The nearest 2 power.
2 power 5, right?
Yeah, 2 power 5, which is 32. 32 plus 9, 2 power 5. So this 9 is the L now. So our answer is 2 into 9 plus 1, which is also 19. 19 is the solution. So Josephus needs to stand the 19th position of the circle with 41 members so that he won't get killed. So that he will be the last survivor. He will be the last survivor in the circle and he will get surrendered to the enemy team to escape from his Roman opposites. Okay, we'll meet in the next meeting. Cut, cut, cut. Okay. Uh, Again, good morning to Arjun, Anbazhagan, and Nithish. We are going to discuss on the second topic, on more on the Josephus problem in a data structures and algorithm course perspective. So, in previous course of course with session with Arjun and Anbazhagan, I have explained about the mathematical terms where the k is the number is fixed or just the just adjacent person is still. But now we are going to for a more defined algorithmic way where any adjacent person or the more different person is skilled also we can find a solution. That is a more user input customized solution. We are going to find it out. So thanks Nitish for joining us in this Nitish sir for joining us in this session. So we will look onto the customized generalized solution for Josephus problem in this one. So yeah, let's get into the problem. Okay, I will share the screen also. Screen aspect. Sorry for not doing it also. Yes, it's okay. Yes, yes, yes. Yeah. Oh, I hope the screen is visible and clear. Yeah, it is visible.
Yeah, it's just,
Okay. So previously we have seen when the in a Roman problem where Jews are killing themselves in adjacent manner one by one. So in that case, we have formulated the solution for uh, formulated the solution in a mathematical set like data set approach point of view, and then find the solution as 2L plus 1 using some mathematics. That is very well done, but we are not going to look into this mathematical aspect of it. So we will just first read the question and then we'll see how it goes. The solution is like we have taken the k as a fixed, but now the k is different. So I will read the question and I will explain what is the question is. Given the total number of persons n and a number k, which indicates that k minus 1 persons are skipped and kth person is killed in a circle in a fixed direction, which means given a a total number of persons n. So let's suppose the n is fixed 1, 2, 3, 4, 5, tick tick n, and and the number k, which means they are giving a input in a function. They are giving just int n and a int k. It is not much of like you can just assume the input to be of n and k. I am writing in a computer function that system function that doesn't need to be much. The pseudocode is pretty much enough. So the input is n and k. What they mean is n soldiers are standing, n persons are standing, and k, the number k, which indicates that k minus 1 persons are skipped and kth person is killed. Which means, let's suppose k is 3, which means k minus 1 is 2. K minus 1 is equal to 2. Two persons are skipped and the third person is killed. So two persons are skipped in the sense 1 and 2 is skipped and third is killed. 4, 4 and 5 is skipped, 6 is killed. So there is two gaps in this new scenario where k is equal to 3. In our previous scenario, if you have seen, there is only one gap. Like only one person is left. That everything like it goes on a circular way. So now the k is changed. But even they can give k is equal to 4 or k is equal to 5 and can find us and can ask us to find the solution for that case. So we want to generalize an approach. and then we want to generalize using any approach, and then we will uh, we'll write a function defined for this in a pseudocode manner, like in a easily understandable logical manner, and then we will uh, get the outputs. Like let's suppose n is equal to 3, k is equal to 2, the output there are okay. We will solve this input as such, and we'll give more clarity for you. N is equal to 3 and k is equal to 2. 1, 2, 3. K is equal to 2 means k minus 1 is equal to 1. I have said skip k minus 1 persons in the question. K minus 1 persons are skipped. So k minus 1 is 1, so 1 person is skipped. So 1, if 1 is having the square, so like it basically means 1 is skipped, and like in our case the SWAD logic is different, this logic is different because you have to see from the outer perspective of k. In that case the next person is killed, that is different. In this case 1 is skipped and 2 is killed, like it should be taken in that case like 2 is killed, so killed means I will put like this, and then 3 is skipped, 1 is killed, so 3 is the solution, so output is 3, they are meaning that. So that case, that k number you don't want to take it into account because we are not seeing in the perspective of a soldier. Now we are seeing in the perspective in the overall, in the like you are seeing it in a computer. Like think like that. You are skipping one and removing two. You are skipping three and removing one. In that case, you want to move now, rather than thinking that one is killing two, two is killing three, is killing four. Not like that. So that this idea of skipping two, skipping three will make a more clearer idea on what we are going to do in this problem. So this also goes in the same way. What we are going to do is we'll find solutions for a smaller set of problems and we'll make it applied for the larger set, any set, using recursion. We'll see what recursion and what the idea is in a pretty much few minutes. So yeah, the task is to switch in the safe place in a circle so that you perform these operations. Starting from first place in the circle, you are the last one remaining and survive. It is basically the same Josephus problem. We want to escape from killing. They made it in the different way. That's it. Yeah. Yeah, they also said the same thing. That there are three persons, so skipping one person, that is first person, second person will be killed. The person safe person is three. Explanation is not needed. We will get on to the solution part. I will explain that part here. This algorithmic way for killing next person is done. If just k is equal to for two k's, we can define just write the equations for that algorithm and get the answer. But that is not our whole point. When we have a better approach, so we'll just find the answer for any k. So we will just do the same thing and we'll try to get answers one by one. So yeah, I hope things are clear. So I'll draw a line. Okay. Wait a minute. I'll find the shape. Okay. Okay. Yeah, now it's lining. So thing is, uh, yeah, it's fine. Now we are going to draw for 1, 2, 3, 4. Let's keep it simple. 1, 2, 3, 4, 5. We'll start with that. Now our approach is different. Previously the approach was different. In like we want to say write a code for machine to solve. Previously we write a code for any mathematicians to solve or many mathematicians to understand. Now the machine should learn and understand. So we will write for that purpose. So we'll write 1, 2, 3, 4, 5. So the answer, let's suppose uh, for a question, if you see the k value is fixed, what they will give is function of n comma k. K is fixed in a question. In a question, for same k they can give different n. For different n they can uh, like different n they can give different k also. That both are independent of each other. But what happens, we'll look one by one. Like I'll just explain that. That comes on like that comes easy while explaining. Give it rather than giving the overall idea first. So let's suppose a simple case of n is equal to 2 and n is equal to k is equal to 2 and k is equal to 3. So for k is equal to 2, the solution is very simple. We will skip 1, skip 1 comma 2, skip 1 and 2. So we'll skip 1 in the sense we will skip 1 and then we'll kill 2. We'll skip 3 and we'll kill 4. We'll skip 5 and we'll kill 1. Skip skip 3 and we'll kill 5. So the solution is 3. We'll check it out with the above one. Is the solution same or not for 5? Yeah, the solution is 5 third is the safest location. So we'll write it as for function of phi n is equal to 5 and 2, I mean k is equal to 2, the answer is 3. For function of 5 comma 3, we'll check what is the answer. 1, 2, 3, 4, 5. So now we will skip 2 people because k is equal to 3, so you want to skip 2 people. So 1, 2 will be skipped, 3 will be killed, 4, 5 is skipped, 1 is killed, 2, 4 is skipped, 5 is killed. So now it is even more careful. We want to skip 2 things and there are only 2 people and starting from 2. 2 is skipped, 4 is skipped, 2 is killed. Because 2 and 4 is skipped and then again it came to 2 and 2 is skipped. So 4 is the solution right now. Okay. Is that understandable? So the answer changes for different n value. So what you can look at is uh, uh, am I audible? Is things are
Yeah,
clear?
yeah, yeah, audible.
Things are clear right now. This okay. Okay. Let me take a break for a second and then I'll give it an overview idea. Okay. As 1 minute break is needed now. Yeah. Let's continue. Think this. Uh, I want to say you think about recursion. What recursion is? Recursion. I'm just making it bold so that this is the most important thing which I'm going to do. So what recursion is? Does anyone of you have idea on what recursion is? Recursion is a mathematical like it is not a mathematical. It is a concept in computer science. Like a function repetitive calling. So I'll just say what recursion is. Recursion basically means that you are doing a thing repetitively, a function repetitively until a condition is satisfied, until a condition is not met, or whichever thing is. So what you will do in recursion is the very best example for recursion was factorial problems. If you see 5 factorial is 5 into 4 into 3 into 2, 1, or which is 5 into 4 factorial, right? So what is 4 factorial? 4 factorial is 4 into 3 factorial. 3 factorial is 3 into 2 factorial. So what we will do is we will just define 1 factorial to the computer, that 1 factorial is 1, and we'll say 2 factorial as 2 into 1 factorial. 3 factorial as 3 into 2 factorial. So what it will do actually is n factorial as n into n minus 1 factorial. Okay. So what the computer does is basically whenever you need something, it will like function of like factorial of n you will put, and then you will type return, which means uh, return the answer as n star n minus uh, factorial of n minus 1. So what it will do is it will multiply n into factorial of n minus 1. Basically, that will again call this function with integer n minus 1. So what it will do is n will like n will call n minus 1, and then n minus will call n minus 2, and n minus 2 will call n minus 3. It will go on until some 1 is reached. So one value it knows, so it will calculate the previous thing, it will calculate the previous thing, it will calculate the previous thing, and we will get n factorial. So this is how it goes, okay? So basically, if you know the solution for a smaller thing, you can find a solution for a larger thing. Is what recursion, the whole idea of recursion is. Okay? That is what the recursion is basically comprised of. So my video is done. Okay. So that is the idea of recursion. So what we are going to do with that recursion, the Josephus problem is we are going to define the solutions for smaller problems and then find a relation. For now, you know that n into n minus 1 factorial, but in Josephus problem, you don't know the how to do that. So in Josephus problem, you will find that relation now, and then you will put that relation in the small pseudocode function, and then we'll get our answer. Okay, it's that clear?
Yeah. Yeah.
Idea is clear, right? Any doubts on what where are we going, or Anbazhagan, do you have any doubts?
No doubt on no.
No doubt. Super. Okay. Okay, that's pretty much. We'll start with the recursion thing. Basically, recursion thing, we want to find relations between n and n minus 1, the n and the previous thing. So now we'll do the basic thing, 5 and 4. We'll keep the, so we can keep the k fixed in this, and then we'll find the relation with n and n minus 1. So let's keep k is equal to 2 for simple purpose, and try finding relation between n and n minus 1, between n and n minus 1, or 5 and 4 5 minus 1, which is 4. So for 5, what we will get is, we'll draw like this. Why does, okay, not an issue. 1, 2, 3, 4, 5. So the solution goes like 2 cut, 4 cut, uh, and then 1 cut, 3, 5 cut. So 3 is the solution, this is the solution. For another thing, 4, 1, 2, 3, 4. So 2 cut, 4 cut, 3 cut. So this is the solution. Uh, so you want to figure out, like, create a pattern in which you can. Okay, I will create another pattern. So 4 is done. So I'll create for 3 also. 3 as well. 1, 2, 3. So now 2 cut, 3 is left, 1 is also cut. So yeah, 3 is remaining now. That's all right. 1, 2, 3. 1, 2 is cut, 3 is cutting 1, so 3 is remaining. So what you can try to do is, you can put all these on, like, all these answers on, like, a on a, what you can say, mm, yeah, all these answers in such a way that it gets a relation to with the numbers. I'll, like, try to figure it out with you that. In this thing, if you have seen, for 4 the answer is lies in here, like the 1 is the answer. For 3, the like, for 3 n is equal to 3, the 3 is the answer. So what you will try to make down from this is, yeah, we'll try to change the order of the number so that it matches with the solution. Like, let's rotate like this. What we'll do is, let's rotate this. So 3, if the 3 comes here, it will match exactly where the 1 is there. 1 is there, and then 2, and then 3, you can put it here, 3, and then 4. Now 3, if it goes there, it goes like 2, 1, 5, and then 4. So we will catch up this order alone. Like, as it is only 4 here, for that we will catch up this order. Okay. And then we will write for a new thing. We will write in relation that the position, if the position of, like, this position is the answer. So 3, the position of 3 and 1 is linked. If 1 is changed to 3, the solution you will get, like, you will get the solution. So we will get to change the numbers exactly from n minus 1 to n. The entire numbers will be changed. Basically, like 1 plus 2, 2 plus 4, 3 plus 5. I'll write it down and show. So 3 is changed to 1, 4 to 2, 5 to 3, 1 to 4, I guess. Yeah, 1 to 4. Basically, what happens is, if 3 is changed to 1, like minus 2 is done, the another sequence of 4 is created. Like, this is for, I will write that as well. N is equal to 5. This is for n is equal to 4. Here also, this is solution. So that solution thing you don't want to think much. If this n is equal to 5 sequence is changed, the numbers of the n is equal to 5 sequence is changed by reduction of 2. Like 3 is changed to 1, and 4 is changed to 2, 5 is changed to 3, and 1 is changed to 2. This alone we will look at later. If the numbers is changed in this way, we will get the same pattern as n is equal to 5 and the solution can be repeated. Here's some, okay. So what I want to say from this is, there is some pattern in this. So if you look lower on, like from 4 we can find 5. You can just make this arrow reverse as well. Okay, this thing doesn't matter. So from 4 you can find 5. So if you just add plus 2 and then make a thing, from 4 you can find a 5. And 5 you can find 6 and 6 you can find 7. So I'll just repeat the things again. Like this logic and all we want to figure it out. So I will repeat the same thing for Anbazhagan. From this thing, what you can find is if n is equal to 4 you can add something or can do some mathematical operation like modulo or something and can find the solution for 5. You have 1, 2, 3, 4 in n is equal to 4. And from that, you can make plus 2, plus 2, plus 2 and we'll get the same sequence in a different way. And that and there you can find n is equal to 5. From n is equal to 5, you can find n is equal to 6 and n is equal to 6, you have different thing. So we have to figure out that thing. So what is that? What is done from n is equal to 4 to n is equal to 5 is what we are going to figure it out. So if you can see it clearly say that only can say that. Okay, I will take this. Okay, this one is completed. Okay. Uh, plus 2. Okay, that's okay. Uh, Only plus 2 is added. Plus 2 is added and all, and then it is converted. But that is wrong because if you add 4 plus 2, it will give to 6, but 6 is not there. So what it is done there? Can anyone say why instead of 6, 1 is written there? The logic of plus 2 may be correct, but that doesn't apply when fourth people plus 2 gives sixth people, but n is equal to 5, you can't put 6, so they have written 1. Like how they did that? What is the mathematical operation which you can try to use?
The sixth person will be since they're not six people, sixth person will be like maximum you can go till five and then
Uh,
one.
yeah, it is
Five plus
basically
one.
like a repetition in a circular fashion, right? Anbazhagan, can you say some mathematical functions to do that repetition of 6 as back to 1, like in a circle of only 5? So what it is basically is making a circle of only 5. 1, 2. If the 4 wants to move 2 times, 4, 5, 6, 4 wants to move 2 times. Instead of 6, it wants to go to back to 1. So it is like a circle of just 5 numbers. It is not. It cannot exceed that. Is there any mathematical operations to do that? You have to operate on 6 and make it 1. Is there anything? I think of it.
Anna,
Say.
okay now.
Like any mathematical operations, can you think to make 6 as 1 or 7 as 2, 8 as 3, like that? Okay, I will give a hint. So what you can do is you can take 6 modulo 5. Modulo. Modulo means remainder. Remainder is something which will give the answer only in the range of 1 to 5. Yeah, remainder cannot go above 5, right? Or else it will go, if it goes above 5, that number can be get into the 1 for the question. So 6 modulo 5 is 1, 7 modulo 5 is 2. Is that clear? So what happened here is you are adding plus 2. That plus 2 makes it as 6, but that number is modulo with the 5. 5 is nothing but the n. So what you are doing is you are making the number. The number is nothing but f of n minus 1 of k. You are adding it plus 2 and then that number is made modulo 2. Modulo not modulo 5, that number is modulo n. So that you will get f of n of k. Is that understandable? Basically, every number function means every number, right? You have seen functions as basically as a mapping. So every number in f of n of k is basically created by this approach. Like basically using a plus 2 and then a modulo. Let's suppose you try for this. A number of 1 in this. Number of 1 in n is equal to 4. F of n is equal to 4. 1 is 1 plus 2 modulo 5, which is equal to 3. Right? So that is the same. Modulo 5 will give you like the same thing. I don't want to write this more. It's too much complicated because the equation is more important. Not to make them messy. So, so yeah. N is equal to like this 1 plus 2 modulo 5 if you put, or modulo n. The n is this one. We are finding n through n minus 1. So that is the idea, right? Idea for recursion. So that is the idea for recursion. So we are taking modulo by n. Why we are putting it n is, we want, like if the n is changed, like we cannot write it as 5 because if the n is changed, we want to change the modulo operation accordingly. So we are putting it as modulo n. Okay, is that clear up to now? Is that clear?
Clear now.
Okay. In our case, if you have seen, it is 2k as 2, right? So that it works. But for a generalized case, we want to think on that as well. So what we will think on that is, so basically f of n of k is equal to f of n minus 1 of k. We'll write that as first, and then plus this 2 is also changing as per k. How it changes, let's look at that. We can take another example and look at that, but we'll just try to identify with this as well. What you can look at is, yeah, what you can try to look at is, it is plus 2. So plus 2 is basically, in our case, it is a k. You cannot just write this as k because there is a problem with that. I will let you know. Like, let's suppose, let's take the case of, hmm, uh, what you can take. Just a minute, I will say this one. Like 6 plus 2 modulo 5 will give you 8 by modulo 5, which is 3. And 6 plus 1, like, I mean, 7 by modulo 5 or 9 by modulo 5 plus 1, like, or plus 2. That will give your answer as 4 plus 1, 5. So, basically, uh, basically what you can try to do is, okay, Lawrence, I will just think on this as well. Because I have a small confusion. We can just write k here, but I'm just thinking on whether to write k or k minus 1. Whether the modulo operation inside and outside will change as such. Because if you're adding and taking a modulo, like what I am thinking is whether to write it as k minus 1 plus 1 and this plus 1 out of modulo, or just this as k and after taking it as a whole modulo. I want you to think as well whether writing it as k minus 1 and then 1 outside the modulo. Because 1 outside the modulo will make the value always plus 1 in default. If, yeah, that is 1 outside the modulo will make the value always 1 in the default, even if it is divided by the modulo. Yeah, so much things to say in this one. So that's one problem with modulo. What is 5 modulo 5? Modulo means remainder, right? What is 5 modulo 5?
0.
0. So let's suppose if this number comes as n. In some cases for 7 and all, if you've seen, the solution is 7 itself, right? Let's suppose if the number comes as n modulo n comes as 0, which we don't want. Rather than we want the solution as 1. Is that right? Is that correct? Like instead of, like, what I'm meaning is, if the number comes as 5, the number can be 5. Like the number can move on and can go for 6, not like just sitting at a 0. basically in computer, like the remainder goes in 0 rather than we want the remainder get started at 1. Like, uh, I can say it even more clearly. Like, let's suppose, uh, let's take this case. There is only 5 numbers. The problem is 0 shouldn't be coming, but modulo operator provides 0, so that we are going to make it plus 1. I will say through this one. Uh, okay, okay. 3 plus 2, 3 plus 2, 5. Okay. Wait a minute. You can take the example like this. Uh, in some case of example where example itself can be more generalized rather than providing for the case where there is an addition and then you are getting a 0 because modulo operation can provide 0 but you don't want 0 in the output because we are writing it only with the solutions like n numbers. So what you will basically do is you will always have plus 1 on the side when the entire thing is getting divided by 0. So what you will do is instead of okay instead of, okay, what I will do is just write k and then divided modulo n, the answer can be 0. Can be, because the screen is not that much good, can be 0 at sometimes. But we need 1 at that case. But that is not possible. But n can't be 0. N can't be 0. N cannot be 0. So what we will do is, we'll do a small thing. Just a small thing. What it is? F of n minus 1 k plus k minus 1 and then modulo n, the larger operation, you will do modulo with that and then you will add plus 1. That is the equation that we are going to deal with. Is that clear? Like this is how the mathematics works. Like when you change it from one to another. When you are using a modulo operation, you will get 0. So you want to encounter that. You will add plus 1 later and then subtract while before taking the modulo. Actually, it is a difficult interview questions asked in many like Oracle, Amazon, Microsoft. So they will check every point of view on how you think and how the solution is. You have to think in practical cases as well, not just by writing K there. So this is wrong. This is the reason this is wrong. So wrong because produces 0. Is that clear? Is that clear?
Yeah.
Okay, okay. Hope the
Clear.
is that clear? Okay, then what we can do is we can just pause it down. Okay. Okay, now if you have seen the equation, we have written f of nk is equal to f of n minus 1 k of k plus k minus 1 mod. I have explained this. This equation is wrong because it produces 0. Which means like 0 is included in the 1, 2, 3, 4, 5. But they said it starts from 1. So as per the question, we are not using this equation. So we are sticking to this equation of nk is equal to f of n minus 1k. Basically what it does is this equation asks for the solution from the f of n minus 1k equation and in that solution, okay, my audio is clear. In that solution, it will do. Is my audio clear?
Clear, Anna.
In that solution,
Clear.
it will add k minus one, which is the steps skip, like the present skip. Will add that skipped for pills, and then we'll do modulo. Sometimes modulo happens, or the same answer will be repeated of these two, and then plus one is added, so that you will get the solution for f of n. So using n minus 1, you will get the solution for n. So for but n minus 1 gets a solution from n minus 2 and n minus 2 gets a solution from n minus 3. It goes on until the number reaches 1. Because we know the solution for f of 1 of k as equal to 1. When there is only 1, whatever the skip you do, the solution is just 1. So we will go until this recursion, this thing will go until that and will make this 1. So that is how the solution works. So let's do a basic thing and then we'll check how this recursion gets the answer for this. So let's put f of 1 of 3 of k That will give us f of 2 of k, and k can be set as 2. So 2 comma 2 plus k minus 1 is 2 minus 1 1. Modulo n is 3, right? So plus 1. So what it gives is the solution for 2k we don't know. So we'll find from f of 2k, we will find from this one. Again, the older equation where f of 1k will use that, and then plus 1 modulo 2 plus 1. So for this, you will get the answer for f of 2 comma 2. The answer is 1. 1 plus 1 2. 2 modulo 2 is 0. 0 plus 1 1. So for that, so you'll know now the answer is. So I'll change the pen color alone. The pen color. 1 minute. The pen color I will have this one. So through this, we have find the answer for f of 2 comma 2. This 2 comma 2 will put it on 3 comma 2, the older equation, and will 1 plus 1 modulo 3 is 2 is the answer. So 2 plus 1, 3 is the answer. So now you know that f of 3 comma 2, the answer is 3 given by the equation which we found out, which is actually correct as verified previously. So if you've seen here, the 3 also, the answer is 3 only for k is equal to 2. So our equation is correct. You can identify through this. Like I just substitute k because we know the values of k previously. And just by substituting f of 1 of k in the predefined previous equation, we understand that the recursion works, this problem works smoothly and find the answer. So this is how it works. So what we will do further on this is, we'll just write a code for this. The code is the code is basically if n is equal to 1, this is right, you don't want to see that much. If n is equal to 1, return 1, and else, or if in the different case, what you will do is just can write else in this case, but you don't need always. Like if you are putting it on a larger function, you don't need else. Like you can just define the function in Josephus. I will just clear that. N equal to 1 return. In other case, what you will do is if the if statement doesn't go, if n doesn't go into n, what you will return is return f of n minus 1, like the function of n minus 1 k plus k plus k minus 1, the old modulo, this whole right moment. I'm just writing the above equation. Whole modulo n plus 1 is the written thing which we are going to do. So this will be written. So you can add another bracket as well, not a big issue for plus 1. So this is how it goes. This everything is inside a function. Inside a function of in Josephus or whatever you call it. That is the pretty much C++ code for this. Like a public class is defined, class solution. If in this class what will happen is the int n, this will get the two functions as input, and then if n is equal to 1, it will just basically return 1. If n is different number, it will get n minus 1. It will call n minus 1. So n minus 1 will be called back to here, and then it will check if n is equal to 1, else n minus 2 will be called, and it will go on until n is equal to 1 is reached, and then n is equal to 1 will be substituted in the back equation, and then the after getting n is equal to 1, the equation will get back multiplied, and it will reach up to the end point. Like 5 means it will take the value of 4, 3, 2, 1, and then we will do the calculation and we will give the answer. I hope the solution is clear. This is a small solution. It may look very small in the C++ code, but actually it can solve for any n and any k. Okay. I hope this creates a lot of curiosity for Anbazhagan and Arjun in this meet. If there is any doubts, you can reach me anytime. Yeah. Any doubts or any idea on how this data structures, how this algorithms work, how this aptitude in this works? Are there any suggestions? Is the solution clear? It may be a bit difficult to understand the last part, but if you try repetitively on your own by solving the question, the same question again 2, 3 times, you will get to know it exactly in an easy way. I think a lot of time has been given explanation. I hope it makes it clear. Any doubts, Anbalagan?
No, no.
Okay, Arjun.
Yeah, no.
Yeah. Basically, Anbazhagan is a 12th computer student and Arjun is a BTech mechanical engineering student. So my DFC assignment has been done successfully with your help. Thank you for your like.